Welcome to this lesson on different types of functions. Today we're going to talk about 4 different types of functions, the first one being a one-to-one function. So a one-to-one function really explains exactly what it is. So every one output has exactly one input. So to be a function, every input has to have only one output. But in order to be a one-to-one function, it has to be that every input has its own output and every output has its own input. So when you're looking at the Venn diagrams, first it has to be a function. So every one-to-one function is a function. Only some functions are one-to-one. So we can write that down. All one-to-one functions are functions. Some functions are one-to-one. Okay, so for example, down here we have a function because each input has its own output. But it is not one-to-one because of the fact that this output of 2 has an input of 3 and an input of 0. This one over here is one-to-one because every single input has its own output, so it's a function. Now it's one-to-one because every output has its own input. Okay, same thing up here with the table. We know that based on the table, this is going to be a function because I have no repeated x's that give me different outputs. And every input gives me its own output, and every output connects to only one input. So everything just has to have one line connecting it. All right, so linear functions. Linear functions are like your linear equations. They're going to give you the graph of a linear function is going to be exactly that, a line. So when you talk about a linear function, the linear functions are going to be one-to-one functions. Because in order for it to not be linear, it would have to curve, and if the line curves, it has the potential of not being one-to-one. But if the line doesn't curve, it would have to be one-to-one. Okay, so a linear function is easy to tell by the graph. If I give you a table and ask you to determine whether or not this gives you a linear function, yes, you have to determine, is it a function? So based on my inputs and my outputs, yes, this is a function because every input has one output. We're not worried about whether or not it's one-to-one. When we're talking about linear and we're determining it from a graph, we look at the change. So as I go up 1 over here, I also go up 1 over here. So I went up 1, so up 1, up 1. My change is constant, so since my change is constant, it's a linear function. Now, the only thing that I caution you on, let's say that all of a sudden I go from 3 to 5. Well, now I went up 2. I can tell from the table that my output is my input plus 2, so this would be 7. Well, here I also go up plus 2. I can say that that's constant because I know that in between here, if I put in a 4, I would get 6, and that would still be a constant change. So that would still be on the line. So you're looking to make sure that your sequential domains give you a constant change in your range or a constant change in your output. Okay, so you have to be careful because sometimes they might trick you with jumping up by more numbers, as we did here by going from 3 to 5 and then 5 to 7. And now all of a sudden you went up 2 and went up 2. What I do want you to understand is, let's say that every time you went up once, we had 0, 1, 2, 3, and it was plus 3. So this is 3. Or actually, let's say it was times 2. That'll make more sense. So if we do times 2, so 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is 4. 3 times 2 is 6. So every time I go up 1, over here I end up going up 2. I went up 1, I went up 2. This change is the one that has to be constant. So as long as this change is the same and follows the same pattern, you know it's a linear equation or a linear function. All right, so then the other piece of it is, what is it going to look like? What is the equation of a linear function going to look like? Well, we know that linear equations take the form of y equals mx plus b. So instead of y, we'll have f of x equals your slope times your x plus your y-intercept. That is typically the form that you will see linear functions written in. All right, moving on to exponential functions. So exponential functions, your graph is going to look something like this. It's going to be fairly straight and then all of a sudden shoot up really, really fast. Or it could be fairly straight and then go down really, really fast. Okay, so graphs that look like this are going to be exponential functions. Okay, so an exponential function is a function that gives you a quickly increasing or decreasing graph, and it shows you that your output changes quickly. So here is plus 3, but then all of a sudden we went from plus 3 to plus 18. Okay? And then we went from plus 18 to plus, and you can double check it by doing your subtraction. 11 minus 7 is 4. 7 minus 2 is 5, so it ended up being plus 54. So you're seeing that the change is increasing drastically and very, very quickly. So a quick change means that it's exponential. So a rapid change equals exponential. And again, it could be going down because this could be negative 3, negative 9, negative 27, negative 81, negative 243. Okay, so it would still be plus a negative 3, plus a negative 18, plus a negative 54. It doesn't matter. As long as this change is rapid, it's an exponential function. When you have an exponential equation, typically that's going to be your f of x is equal to some number to the x power. Okay, so it's going to have x as your exponent. There are graphs where you talk about like if x is squared, and we will talk about that, or cubed or anything, but when we're talking about an exponential function, typically we're talking about your x as your exponent. A quadratic function. Okay, a quadratic function is where the input is squared and the graph is a parabola. And parabola is a U-shape. So when you see this U-shape, this curve in your graph, you know that it is a graph of a quadratic function. So if I put a graph on the board, you should be able to tell me quadratic, exponential, linear. When you look at a table, you should be able to look at the connection. Okay, if I square negative 2, I get positive 4. If I square negative 1, I get 1. If I square 0, I get 0. If I square 1, I get 1. The only thing that you have to watch for is, let's say that it was x squared plus 1. Okay, because then this would be 5, and this would be 2, and this would be 1, and this would be 2, and this would be 5. Okay, so typically what you're going to end up seeing is you're going to see that your opposites have the same output. And they're still the same. They're not opposite in terms of positive and negative. So when you're looking at a table, what you're kind of looking for is, okay, are my opposite inputs giving me the same output? So again, this is a function, but it's not a one-to-one function because 4 has an input of 2 and an input of negative 2. So quadratic functions are not one-to-one. If you want to write that down as just kind of a thought. For the equation, you're going to have f of x is equal to x squared. Okay, so it's always where your x is being squared that gives you a quadratic function. So this has to stay the same. Now, let's say you had f of x equals x squared minus 1. Okay, that's just going to move your parabola. If you take, specifically what I do want you to know is if you take your function and you make it negative, that's actually going to flip your graph. So instead of having a u that opens up upward, you're going to have a u that opens up downward. So when that negative is out there, you need to know that it's going to flip your graph. And the last one, absolute value functions. Absolute value functions as a graph give you a v. So the nice way to remember it is absolute value. Value starts with a v is going to give you the v-shaped graph. Again, what you're going to look at here is that your opposites give you the same outputs, but in this case, so whereas before when it was squared we had 4 and 4, now it's giving you the same output. Okay, so negative 2 and 2 are giving me the same output, but my output is also the same as my input. It just might be the opposite number. So instead of like when I have it squared, it's 2 and 4 and negative 2 and 4, this is going to be negative 2 and this output should be 2. Okay, so your output is going to somehow kind of match your input. For the equation, you're going to have f of x is equal to the absolute value of x. Okay, again, if you take it and you do the negative on the outside, it's going to flip your graph. So it's going to give you an upside down V. And there are little other changes that occur. So let's say I have f of x is equal to, and I have inside of my absolute value, I say plus or minus a number. So let's say I do plus 4. Since it's inside, it's going to move my graph left or right. So I'm going to type this so it goes a little faster. So inside moves graph left or right. Subtracting would move it left, adding would move it right. Okay, and that kind of it goes along smoothly with saying, okay, well obviously subtraction is left, addition is right. What if I move that to the outside though? So let's say I do f of x equals, and I keep the x inside but add the 4 outside the absolute value. When it's outside, it moves the graph up and down. Okay, so outside moves graph up and down. And again, the positive or adding would move it up, subtracting or negative would move it down. So with all of this is just a lot of memorization and kind of working through it. As always, if you have any questions, please be sure to write them down or email me so we can go over them in class.